Okay, so today we're going to be looking at chemical reactions and seeing whether or not two aqueous solutions can form a precipitate. We're also going to learn about ionic charge and how to balance those charges, and also how to balance the final equation and decide whether or not something forms a precipitate or just has spectator ions. So our solutions today are silver nitrate and sodium sulfate. So the first step is to have a look at their ionic charge. So silver has a charge of +1. Nitrate has a charge of -1. That's good, that means that they're balanced. +1, -1 means we can keep our silver nitrate just as it is. Then we look at our sodium sulfate. So sodium has a charge of +1 and sulfate has a charge of -2. As you can see in this equation here, the chemical formula for sodium sulfate is 2 sodiums for every 1 sulfate. So what that means is, as you can see, sulfate is -2, sodium is +1. So we need to have the same charge so that these can be balanced. So to do that, we need to have 2 sodiums for every 1 sulfate, and that's why this little 2's here. So now we have our balanced charge. We can have a look and see what happens when we have our cations and our anions mix. So we're going to look at the cation silver, and that is going to mix with the anion sulfate from the sodium sulfate, and then we're going to look at the sodium cation, sodium, and then the nitrate anion. Now we need to do the same thing. We need to check to see their charge. So silver has a charge of +1. Sulfate has a charge of -2. So you can see -2 +1. We have to do something to the silver. So what we actually need to do is have 2 lots of the silver to make our charges the same. 2 times 1 is 2. That makes us have the same. And if that's the case, what we need to do is put a little 2 here in between the silver and the sulfate. Now we have 2 silver ions, or 2 silver atoms for every 1 sulfate. Now let's have a look at the sodium nitrate. So sodium has a charge of +1, and nitrate has a charge of -1. They're equal, so sodium sulfate stays in the chemical formula NaNO3. So far we're going well. Now we need to check to see whether or not our atoms are balanced. So first of all, let's check our silver. We have 1 silver on this side, so on our reactant side, but here we have 2. That means that we need to balance our silver atoms. So now we need to put a 2 in front of this silver nitrate. That now means we have 2 silvers, also we have 2 nitrates. So let's check our nitrates next. No, we've only got 1. So now what we need to do is put a 2 in front of the sodium nitrate. So now we have 2 nitrates here, but we now have 2 sodiums. So let's see whether our sodiums on our products side, which is this side, is 2. And let's have a look and see whether or not our reactants have 2. Yes, they do. So our reactants have 2 sodiums and our products have 2, balanced. Let's check the sulfates. 1 sulfate, 1 sulfate. All good, we're all balanced. So now we need to check to see whether or not there's been a precipitate form. So let's look to see what the rules are for sulfates. So most sulfates are soluble, which means that they would be in aqueous solution, except, and there's a list, and in amongst them there's silver sulfate. So that means that silver sulfate actually forms a precipitate. So we put it with an S, which means solid. Now let's check the nitrates, because we've got sodium nitrate. All nitrates are soluble. There aren't even any exceptions. So every single time there's a nitrate, it's soluble. So it means that it can dissolve in water. So now we've got our equation. We have 2 lots of silver nitrate and 1 sodium sulfate. And then we have our reaction, and our products are silver sulfate and 2 atoms of sodium nitrate. So now we need to work out what is our precipitate. Well, we can see that our precipitate here is silver sulfate. So we do silver sulfate, and the silver, remember, has the 2. So there's our precipitate, silver sulfate, and that will always have a little S there to show that it is actually a precipitate. Then we need to have a look and see what our spectator ions are. So our spectator ions are the ones that stayed in aqueous solution. So there we had our sodium ions and we had our nitrate ions. So from our reaction, we've ended up with a precipitate of silver sulfate and spectator ions of sodium nitrate. Thank you.